for acute angle E, so that's this angle right over here, they tell us that sine of E is 5 over the square root of 41, and cotangent of E is equal to 8/10. Find the values of the other four trigonometric ratios. So for the trig ratios, I like to use SOHCAHTOA to remember what the definitions of the trig ratios were. So let me write this down. SOHCAH, I'll write CA in, let me do it in a different color. SOHCAH, no, that's not a different color. I'm trying to having trouble changing colors. SOHCAHTOA. SOHCAHTOA. So tells us that sine of an angle, and in this case we care about angle E, is equal to the opposite over the hypotenuse. Well, if we look at angle E, what is the opposite? Well, we go across the triangle. The opposite is right over there. That is the opposite, so it would be equal to 5 over the hypotenuse. Well, the hypotenuse is opposite the right angle, and it's the longest side of the triangle. It's side DE and has length square root of 41. Square root of 41. So that's consistent with the information they gave us. So this was kind of redundant information. We could have figured that out just from the diagram. But at least we got that out of the way. Now let's think about the reciprocal of the sine of E, which is the cosecant of E. Cosecant of E, which is just the reciprocal of sine, which is hypotenuse over opposite. And we don't even have to look at the triangle. We could just say it's the reciprocal, which is going to be square root of 41 over 5. Or you could look back at this and try to figure that out. Now let's think about the cosine. What is the cosine? What is the cosine of E going to be equal to? Well, first think about what the definition is. Cosine of E is going to be what? Well, this CA tells us it's going to be equal to the adjacent over the hypotenuse. Well, if we look over here, we know what the hypotenuse is. The hypotenuse is the same. Hypotenuse is square root of 41. Hypotenuse is square root of 41. But what's the adjacent side? What length does the adjacent side have? Well, for angle E, the adjacent side is side FE, and we don't know what that is right over here. So that is the adjacent side, and we don't know what that is. So I'll just write A. A for how they marked it on this, or you could also view it as A for adjacent. So right now we're just going to leave it with this variable A over square root of 41. Maybe we can get a little bit more information that helps us to figure out what A is over the course of this problem. If we wanted to figure out what the secant of E is, well, that's just the inverse of the cosine. It's hypotenuse over adjacent. So it's going to be the square root of 41 over A, whatever A is. Hopefully we can figure that out. Now let's use TOA. That tells us that the tangent of E is equal to the opposite over the adjacent. Well, what's the opposite side to angle E? Well, it has length 5. It's side DF. So opposite is 5. And we still don't know the length of the adjacent side. That's this side of length A. So I'll just write A right over there. Now what about cotangent? Well, cotangent is the reciprocal of the tangent. So it is adjacent over opposite, or in this case, A over 5. Adjacent over opposite, A over 5. But what do they already tell us? And using that, can you figure out what A is? Well, they already told us that cotangent of E is equal to 8/10. There's a little clue here that this is not reduced fully 8/10. 8 and 10 share common factors. So they already tell us that cotangent of E is 8/10. So if we use the definition of cotangent of E, we get A over 5. But they tell us that that is going to be equal to 8/10. So we can write, we have an equation now to solve for A. And if we solve for A, now we can figure out all of the other ratios. So let's do that. So we have A over 5 is equal to, we'll simplify this a little bit. What is 8/10 if we simplify it? Well, if we divide 8 by, they have a common factor of 2. If we divide 8 by 2, we get 4. If we divide 10 by 2, we get 5. So we get A over 5 is equal to 4/5. And so this, you could do cross multiply, and you could multiply both sides by 5. And you would get, either way, you would get that A is equal to 4. Let me just do that just to show that you can do it systematically. And you're left with A is equal to 4, which is great because we can now say that the cotangent of E, yes, it's 8/10, which is the same thing as 4/5. We can say that the tangent of E, instead of saying it's 5 over A, we can now say it is 5 over 4. And now what would the cosine of E be? Well, it was A over 41. Now it is, let me do that orange color. Now it is 4 over square root of 41. And what's the secant of e now? Well, it was square root of 41 over a. Now it's square root of 41, square root of 41 over 4. Or we at least know the value of a. And we can verify that a is equal to 4 by using the Pythagorean theorem. In fact, we could have solved it that way, but the whole point, I'm suspecting, of this problem is to actually establish this using this information, although we could have done it using the Pythagorean theorem. But let's just verify that this a equals 4 satisfies the Pythagorean theorem. So if we take this side right over here, we have 4 squared plus 5 squared plus 5 squared should be equal to the square root of 41 squared. Should be equal to the hypotenuse squared. Square root of 41 squared. So 4 squared is 16. 5 squared is 25. So does this actually meet? Does this actually satisfy the Pythagorean theorem? So 16 plus 25, square root of 41 squared is 41. 16 plus 25 is indeed 41. So at least it's consistent with the Pythagorean theorem. And we are done.